Toyota finally admits the 2.5 hybrid problem, and the fix could be more important than most owners realize. For years, this system was praised as one of the most dependable hybrid powertrains on the road. It powered popular vehicles including the Camry Hybrid, RAV4 Hybrid, Highlander Hybrid, Venza, Crown, and several Lexus models. Drivers trusted it because Toyota hybrids earned a reputation for lasting hundreds of thousands of miles with very few major issues. That reputation still stands, but Toyota has quietly recognized a weakness that appeared in certain real-world conditions. This does not mean the 2.5 hybrid is unreliable. It does not mean every owner will face a problem. It means engineers identified an area where the system could perform better over the long term. More importantly, Toyota developed updates that address the concern. If you already own one of these vehicles, or if you are considering buying one, understanding this change can help you avoid unnecessary trouble later. To understand why this matters, we need to look at why the 2.5 hybrid became so successful. Toyota designed the system around simplicity and efficiency. It combines a naturally aspirated 4-cylinder engine with electric motors and an electronic continuously variable transmission. The result is smooth power delivery, excellent fuel economy, strong low-speed response, and proven durability. Unlike many modern engines, it avoids excessive complexity. There are no turbochargers creating extra heat and pressure. The system is tuned conservatively, allowing components to operate comfortably during everyday driving. That approach helped make the powertrain a favorite among commuters, fleet operators, taxi drivers, and long-distance owners. Many people viewed it as the gold standard for hybrid reliability. However, as Toyota expanded the technology into larger and heavier vehicles, new demands began placing additional stress on parts of the system. The issue Toyota eventually addressed centers around thermal management and electrical load under demanding driving conditions. The problem is not something most owners notice during daily commuting. Many vehicles can go years without showing symptoms. The concern becomes more visible during situations that place greater strain on the hybrid system. Examples include extended highway driving, climbing steep grades, operating in very hot weather, towing lighter loads, or repeatedly accelerating while the all-wheel drive system is engaged. Technicians and hybrid specialists point to 3 related areas. The first involves heat buildup around components connected to the rear electric drive system. The second involves additional stress placed on the inverter during sustained operation under heavier loads. The third involves software calibration that was not always reacting as quickly as engineers later determined it should. One reason this issue can be misunderstood is Toyota's all-wheel drive hybrid design. Unlike traditional mechanical all-wheel drive systems, many Toyota hybrids use a separate electric motor at the rear axle. There is no conventional drive shaft connecting the front and rear. This design reduces weight and improves efficiency, but it also creates additional electrical demands. According to many technicians familiar with these systems, the rear motor itself is generally not the problem. Attention has instead focused on the electrical path that delivers power to that motor. Certain components are exposed to moisture, temperature changes, road debris, and continuous electrical demand. Over long periods, those factors can contribute to increased resistance. Increased resistance generates additional heat, and additional heat can accelerate wear. Before Toyota made updates, some owners and service departments noticed recurring patterns. Certain vehicles displayed hybrid system warnings. Others temporarily limited all-wheel drive operation. Some experienced reduced performance during extended highway travel. Technicians occasionally found diagnostic codes related to inverter operation or electrical management. What made diagnosis difficult was the fact that many vehicles continued driving normally most of the time. From an engineering perspective, intermittent problems deserve attention because they can indicate a system operating closer to its limits than intended. Toyota's response was not a dramatic public announcement. Instead, the company revised hardware, updated software, improved protection for key electrical components, and introduced production changes designed to increase durability. Among the most important improvements were updated cable assemblies, revised connectors, enhanced sealing measures, and changes to inverter control programming. Toyota also refined thermal management strategies to better handle demanding operating conditions. In some regions, owners became aware of these changes through service campaigns. In other cases, the updates appeared through revised parts and ongoing production improvements. Hybrid specialists often describe heat as one of the biggest challenges facing modern electrical systems. Excessive temperatures can affect performance, efficiency, and component longevity. Several experienced technicians have explained that the original design was generally capable of handling normal use, but under extreme conditions, it could operate closer to its comfort zone than Toyota preferred. The updated components provide a larger margin of safety. That extra margin is important because software alone cannot solve every problem. Software can reduce stress, alter power delivery, and manage operating temperatures more effectively. However, it cannot change the physical properties of electrical components. That is why Toyota's improvements extended beyond programming updates. The revised parts use better materials, stronger protection against environmental exposure, improved resistance characteristics, and more durable designs. When the new hardware works together with the updated software, the system can identify heat buildup sooner, distribute electrical loads more effectively, and reduce temperature spikes during sustained operation. Rather than acting as a temporary solution, the changes represent a comprehensive improvement aimed at long-term reliability. Based on reports from technicians and owners, vehicles using all-wheel drive hybrid configurations appear more likely to benefit from these updates. Models frequently discussed include the RAV4 Hybrid, Highlander Hybrid, Venza, Crown, Lexus NX Hybrid, and Lexus RX Hybrid. Front-wheel drive versions generally face fewer concerns because they do not rely on the same rear motor arrangement. At the same time, low failure rates do not mean an issue should be ignored. Toyota's decision to update components suggests that engineers recognized room for improvement. For owners, that means paying attention to available updates is simply a smart maintenance decision. If your vehicle uses the all-wheel drive hybrid system, one of the most valuable steps you can take is confirming whether updated components and software have been installed. Speak with a dealership, ask about applicable service campaigns, and verify that the latest calibrations are present. These updates are not designed to increase performance. Their purpose is to reduce heat-related wear, preserve all-wheel drive functionality, protect expensive hybrid components, and improve durability over the long run. Ignoring available updates does not guarantee failure. Many vehicles may never experience a problem. However, prolonged heat stress can contribute to connector wear, increased electrical resistance, protective system shutdowns, and potentially costly repairs after warranty coverage expires. In many ways, Toyota deserves credit for addressing the concern before it became a widespread reliability issue. The company collected data, evaluated real-world performance, and introduced improvements intended to strengthen the system for future owners. So, is the Toyota 2.5 Hybrid still worth buying? Absolutely. Many experts continue to rank it among the most dependable hybrid systems available today. The difference is that newer vehicles and updated examples benefit from refinements that make an already strong design even better. The final takeaway is simple. Toyota's acknowledgement of this weakness is not evidence that the 2.5 Hybrid is a bad system. It is evidence that engineers recognized a limitation and improved it. The updated hardware and software help reduce long-term risk, improve durability, and provide greater confidence during demanding driving conditions. If you already own one, make sure the latest updates have been completed. If you are shopping for one, ask whether the vehicle includes the revised components. Small engineering changes often produce the biggest long-term benefits. In this case, that upgrade could make a meaningful difference for years to come. For many owners,